So today we're going to discuss a little bit about change of state, latent heat, sensible heat. So first off, we need to go back to BTU. BTU, British thermal unit, the amount of heat required to change 1 pound of water, 1 degrees Fahrenheit. Sensible heat, 1 pound of water, 1 degrees Fahrenheit. So BTU is blank pounds of water times blank degrees temperature change times 1 BTU per change equals a total of blank BTUs. How we can look at this, all this is sensible heat. So let's say if we had water, and water was at 32 degrees Fahrenheit, and this was liquid. And I want to change that water from 32 degrees Fahrenheit to 212 degrees Fahrenheit, but staying a liquid. So we're going to have a temperature change to 212 degrees Fahrenheit. So let's say we have 1 pound of water. How many BTUs would it take to change water from 32 liquid to 212 degrees liquid? So let's take and find out. 212 minus 32 equals 180. So our temperature change, use blue so it shows up. Our temperature change is 180. For our example, you can use 1 pound of water. 1 pound of water times 180 equals 180 times 1 equals 180 BTUs. Bam. So to take 1 pound of 32 degree liquid water to 212 degrees liquid water takes 180 BTUs of heat energy, and that is sensible heat. We can measure with the thermometer. Now for that same pound, taking it from 212 degree Fahrenheit liquid to 212 degrees Fahrenheit vapor requires a change of state. A change of state would be latent heat. So it takes 970 BTUs to change 1 pound of water from 212 liquid to 212 vapor. 970 BTUs. Latent heat. Now if we wanted a formula, we could do that. Water. It's from liquid to vapor. Would be blank pounds of water times 970 equals our blank BTUs from liquid to vapor. Okay, so that's pretty simple. But we also have another latent heat factor, and that's going from 32 degrees solid to 32 degrees liquid. So if I take 32 degrees Fahrenheit solid to 32 degrees liquid, that is a change of state without a change in temperature. So what kind of heat is that going to be? Changing state without changing temperature? That will be latent heat. And it takes 144 BTUs of heat energy to change water from, to change state from 32 degrees solid to 32 degrees liquid. If we wanted that in a formula, we could do that. So ice from 32 degrees Fahrenheit to liquid, 32 degrees Fahrenheit, blank pounds times 144 equals blank BTUs. So if I wanted to take solid, take it ice, 1 pound of ice, from a solid to 32 degrees as a liquid, it would take 144 BTUs of latent heat. If I wanted to heat that up from 32 liquid to 212, it would take 180 BTUs of heat energy. Take it from 212 liquid to 212 degrees vapor, takes 970 BTUs of heat. But what if I wanted to have ice below 32 degrees? Is it possible to have ice below 32 degrees? And the answer is yes. It is, but can you measure the temperature of ice being below 32 degrees? Yes, we can. So let's say we have ice at 20 degrees Fahrenheit. So 20 degrees Fahrenheit, 32 degrees Fahrenheit, let's find out. 32 minus 20, a 12-degree Fahrenheit temperature change. But there is a key to this. Because the density of ice is changing in specific gravity, that's going to be different. It is going to take a different amount of BTUs to make this change of state happen. So here we're going to have a slightly different formula for this. We're going to need our pounds of ice times our temperature change times, now instead of 1, here's what's beautiful, is 0.5. It takes half a BTU to change 1 pound of ice 1 degree Fahrenheit. So it's half a BTU. So if we put these numbers in our formula, I have 1 pound of ice times a temperature change of 12. So 1 times 12 equals 12. 12 times 0.5 equals 6. So this would take 6 BTUs of heat energy to take it from 20 degrees Fahrenheit to 32 degrees Fahrenheit. 6 BTUs. And can we measure that? 20 to 30? Yes, that's sensible heat. So sensible heat takes 6 BTUs to take that ice from 20 degrees to 32. It takes 144 BTUs to make it change from 32 solid to 32 liquid. It takes 180 BTUs of sensible heat to take it from 32 liquid to 212 degree liquid. And it takes 970 BTUs to take it from 212 liquid to 212 degrees vapor. But can you have water in a temperature and vapor above 212? Yes. We can superheat that water to where it's above 212, and that would be steam. And let's heat it up to 220 degrees Fahrenheit. So 220 degrees Fahrenheit. All right, let's do the math. 220 degrees Fahrenheit steam minus 212 degrees Fahrenheit steam. So we take 0 minus 2. Well, we can't do that, so we'll do some quick math here. 10. That'd be 8. And then carries. So we'll end up with 8 degrees. So it's going to be very similar to the solid. We're going to have blank pounds of steam times temperature difference or temperature change times 0.5 BTU or constant equals our total BTUs. So we'll put our work in here. We know 1 pound of steam, temperature change of 8 degrees. So 1 times 8 equals 8 times 0.5 equals 4 BTUs. So water, changing in water vapor from 212 vapor to 220 degrees vapor, the change of temperature without a change of state, that is going to take sensible heat. And it's going to take 4 BTUs to make that happen. So the question is, how many BTUs would it take to go from 20 degrees Fahrenheit solid to 220 degrees Fahrenheit steam at standard conditions? And we'll do the math. It takes 6 BTUs to go from 20 solid to 32 solid. It takes 144 BTUs to go from 32 solid to 32 liquid. It takes 180 BTUs to go from 32 liquid to 212 liquid. It takes 970 BTUs to go from 212 liquid to 212 vapor. And it takes 4 BTUs to go from 212 vapor to 220 degrees vapor. So we'll put our 4 down here. So here we have sensible, latent, sensible, latent, sensible. So let's do the math, find out what our total BTUs would be. 6, 7, 8, 9, 10, 11, 12, 13, 14. Here the 1, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 9, 10, 11, 12, 13. 1,304 BTUs of heat energy to go from 20 degrees Fahrenheit solid to 220 degrees Fahrenheit vapor. And if I wanted to take 220 degrees Fahrenheit of steam and I wanted to turn that into 20 degrees Fahrenheit solid of ice, I would have to remove 1,304 BTUs of heat energy. Right? Thank you.